All right. Good morning, good afternoon, good evening, wherever we are watching this tutorial from. Welcome to another tutorial on designing machine learning system. So today, what this particular tutorial is all about, we are going to discuss this designing machine learning systems. A lot of the times, I see machine learning engineers, I see data scientists who build interesting models and leave these models in their Jupyter notebook and leave these models in their coding environment. And this does not really make sense. And for us to actually use these models, for us to use this model as scale to make good use of these models, I mean, we cannot utilize research papers or models sitting down in a Jupyter notebook. We have to take this model itself from the development area, from the research area to production area. And that is what this entire presentation is all about. So I just to but today is going to be a very wonderful day. By the end of this tutorial, you are going to learn a lot of things. So briefly, we are starting immediately and designing machine learning systems. Before then, let me tell you about myself. Let me tell you about me. My name is Victor Jacob Asukwo. I am the lead for machine learning in Uyo. I started a local community machine learning in Uyo. Originally it was TensorFlow Uyo, but it's now machine learning Uyo. And the idea of machine learning is Uyo is to bring in people, to bring in passionate people, people who are passionate about driving change in our community using the power of artificial intelligence, using the power of AI, using the power of machine learning. That is what this community is all about. Also, I am the lead for Python Uyo. Python Uyo is also a local community in Uyo, Akwa Ibom State, Nigeria, and which is all about creating awareness with Python, what to use Python for, and being enabled with Python to be able to solve problems. And also, I'm part of the Google AI and Machine Learning Network. We work with Google directly on Google AI product and product features. We go around to have tutorials or and sessions, just like when built with AI. From this picture, you can see built with AI, just like when Gemini, when Google released their state-of-the-art machine learning model, Gemini, we had sessions all across the world so that people can know what they can do with Gemini, can be aware of what Gemini can do. Also, I'm a machine learning engineer at Start Innovation Hub. At Start Innovation Hub, we build AI products for companies and for startups. I've worked on a lot of projects and startups. Today, I'm going to talk about designing machine learning systems. Also, I'm a machine learning engineer passionate about generative AI. We have heard about the advancement of generative AI, what we can do with generative AI, the things we can do with generative AI, and I'm a big fan of generative AI because already we are using generative AI. We have seen the different ways, we have seen the different area, especially content generation and content creation, how generative AI is already impacting our lives. Generative AI is already part of us. People use it every day to generate content. People use it a lot of times to do some prompts, simple prompts. Help me write this, review this, write that, and use it a lot to do different things. So moving forward, okay, so this is just an image of a model running some detections on the face on the image, and you can see this the model itself is based on drowsiness. So if you get closer to the model, you'll be able to see facing front, eye closed and eye open and the rest of it. So about our community, machine learning we all actually started not really this year with Python. We started our Python community and not really long we came up to discover people who were also passionate about Python. And that is why we do what we do. That is why we do all these things. To all our community members, our tutorials, our workshops, just like this one is totally free. Okay. This you can also see here in the first image. This is when we had our AI community day. AI community day is a day set aside by community members to come together and discuss and talk about the areas AI can be used to solve problems in Africa. Because we are from Africa and we have a lot of different ways. We have lots and lots of problems to solve in Africa. And this is why we are in Africa. This is why we want to use AI to solve these problems. That is for machine learning. You can see another picture here during our workshop. You can see flyers of our speakers. You can see our flyer. So the link to these communities will be shared if you want to join us, if you want to be a member of our community. We really need you to join the force, to join the drive to solve problems in Africa. Okay, so in today's tutorial, we are going to cover introduction to model designing. We are going to look at potential approaches. We are going to look at models in production. We are going to look at the machine learning life cycle, and we are going to look at machine learning on the cloud as well as deployment tools. So this is just there's a whole lot of more complex stuff, but try as much as possible to explain everything so we can understand and follow up what we are doing. Okay, yeah, so that was not supposed to be there. Supposed to go this way. Yeah. Okay. So to start, MLOps. What is MLOps? I don't just want to I don't just want to go directly into the talk for today. I don't just want to move into what we are supposed to do today. But all I want to do is let's discuss. A lot of people now to build intelligent models. Yes, I mean I've seen a lot of good machine learning engineers out there, and they're like, I can do this, I can do that, I can build this, I'll build this model, I have done this. And the questions I ask is, so after building these models, what next? How do I make money from building these models? After this, what next? And because of this, a lot of people, actually try to go into other fields like traditional front end or back end web development because they can't monetize or they can't really make earnings they expect from machine learning or artificial intelligence. And fundamentally speaking, if you want to live in, let's say you want to travel or you want to rent a house or you want to buy a house in a particular place, you are going to ask yourself different questions. And the questions you are going to ask will be: number one, is there light there? Are there basic social amenities like lights? Are there infrastructures? How is the topography? Are there lights? Are there street lights? Is there water supply? Is the environment friendly? So you notice that on the view on the real side itself, you are trying to buy a house, but you are concerned about other things that comes with this with the house, so that you know if this is a complete house or not. The same thing applies here. We are a machine learning engineer and we are just building machine learning models, sitting in your Jupyter notebook. This is not enough. This is just the first step in machine learning. This is just the first step in machine learning. So people think that after building machine learning models, that is all. You build your model, probably test it in your interpreter, in your Jupyter notebook. That is all. As a matter of fact, according to Andrew Engine, the code you write to build this machine learning model, I'm talking about the statistical, the numerical, the categorical, and the entire machine learning code. Even if, as well as you are being good, this is just the first step. This is just the first level. This is just 95%. This is just 5% of the code you need to write to complete building a machine learning system. What does building a machine learning system means? Building a machine learning system entails that we have to build everything complete. We have to build a complete pipeline for your machine learning application. And this is what this tutorial is all about. In this tutorial, we are going to learn how to build a complete end-to-end machine learning pipeline. We are going to learn how to sort of like design a machine learning pipeline, starting from starting from data ingestion, data engineering, feature extraction, and everything. Okay. So if at all you really want to make good use of these models, if at all you really want to design these systems, if at all you really want to not just have these models in your Jupyter notebook, but push it to the end user out there, that means we need to productionize this model. That is the right terminology for it. We need to productionize this model. And what does it mean to productionize this model? It means taking this model, writing end-to-end code to it, and then taking it to the production server so that it can be used by end-to-end users. That is what it's all about. Writing codes in your VS Code or Jupyter notebook is not enough as a machine learning engineer. This is why it's super hard to get a job, because companies out there, they don't just need people that will be able that can write these models. Must be able to deploy these models, must be able to write pipelines for this model. And that is what this tutorial is all about. So how can we do this? How can we do that? Now I've told you that the skills you have alone is not enough. You need other skills like API development, you need other skills like Google Cloud Platform, you need other skills to be able to orchestrate these models. This means that your train test plate, your model.evaluate is not enough. So how do we do this? Let me introduce to you what we call as MLOps. Okay, what is MLOps? Or some people call it machine learning operations. Machine learning operation is not a tool. The term machine learning operation or MLOps is defined as the extension of DevOps methodology to include machine learning and data science assets as first-class citizens with the DevOps ecology. As you're familiar with software development or DevOps engineering, after building an application, there are certain things you need to do. There are a lot of things you still need to do, especially in the DevOps field, especially in the DevOps area. We have to first write this code, write this application using code. We have to make sure this application is okay at scale. We look at orchestration, and then we deploy it to the server, not just deploying, monitoring this application to handle things like payload, load testing, after handling load testing, to make sure the application is up and running such that it can fit the user, such that it can serve the purpose to the user. This is what MLOps means. MLOps means bringing those terminologies, bringing those methodologies into the field of machine learning to solve the same problem. Meaning that the tools we need in DevOps to be able to write a complete pipeline for an application, we also need that tool in machine learning. And that is what MLOps is all about. The extension of DevOps methodology to include machine learning and data science assets as first-class citizens with DevOps ecology. We also have another definition here. MLOps. MLOps is an engineering and a machine learning engineering. Okay, MLOps is a machine learning engineering culture and practice that aims at unifying machine learning development, that is dev, and ML system operation, DevOps. You want to unify machine learning development and machine learning operation. Have you ever asked yourself, so this model now, how are we going to use this model? And let's say we are building something like speech recognition, image detection, or classification. How do we go about unifying the development of this model and and the operations of this model? Because the actual machine learning starts, the system design starts after you have deployed this model. Okay, so what I'm trying to say is that MLOps allows you to use DevOps methodologies to write a complete pipeline for your application. There's still a lot of things to do. There's still a lot of monitoring, testing, designing, and more specifically, if you are looking at deploying your system on the cloud, on edge devices, server, virtual machines, you still have to do that to be able to, and write API as well. Most times, if you are working with a product team, you need to write an API such that the back end and the front end will be able to consume this API. So ML in the industry is more than training models, and you can see this is by Chip Ume. Machine learning engineering is just 10% of machine learning and 90% of engineering. There's a whole lot to do as a machine learning engineer, and this is Elon Musk replying here. So meaning this information is validated. Trend test split alone is not enough as a skill as a machine learning engineer. And if you don't know who Chip Huyen is, she's a senior machine learning designer on production. We can call her senior ML of production. And she has written and published a book on designing machine learning systems. I recommend that book to everybody that wants to learn about machine learning, engineering, designing machine learning systems, and MLOps. That book provides end-to-end ideas, everything from data gathering, data ingestion, data engineering, to every single thing you need to do as far as designing machine learning system is involved. So value proposition, defining the problem. So first thing first, starting out with designing machine learning systems is which problem are you going to solve? You have to identify the problem, its importance, and their end user personnel. It's important. Okay, it's left for you to say this is the problem our organization is trying to solve. This is the importance, and then this is how the user is going to use it. This is how we want to interact with the user. That's where design thinking on its own comes in. Godfrey Murray's value positioning statement template. So if we don't really know exactly what this means, you can use Godfrey Murray's value proposition statement template. It means, okay, for target customers who need this service, our product and service is products category that benefit this. For example, um, okay, so for example, our product. Or let me just give you an example in this situation. So we can say, um, let me use an example from PayPal. Okay, so let's say for mothers who need real-time care, our product PayPal is an application that provides healthcare benefits to children. Simple. You can use this to measure the value proposition of your product or service. Define the problem, its importance, and end user persona. So talking about the workflow of machine learning based software development, there are three main artifacts ML based software. Once we are looking at artifacts, we are looking at the things that are the things you need to be able to design a machine learning based software. First, you need your data. And we all know artificial intelligence, is based on data. We cannot do anything if we don't have data. AI is a simulation of us. It's only the data it is exposed to. That is what it can do. Okay. Most of the misconception about AI is that AI knows everything. AI understands everything. Meanwhile, on the other side, this is not true. AI is not sent from heaven. AI only knows the data it is fed with. So you need data to be able to design any machine learning system. Later, we are going to talk about other things as regards to data drift, and the rest. So next, ML model. What is ML model? You need the model itself, which is trained on this data. After showing the model, after showing the model, this data, vast amount of data, with time, using the mathematical equation, vectors, algebra, statistics, they are going to learn patterns in this data. That is what the model is. So it is a model that we want to now test, to pass in the test, pass in the test values. We get a prediction, a detection, and outcome. And we need the code. This is the infrastructural part of it. We need the code. We need the code to make sure that the machine learning life cycle is monitored. We need code too, starting from training, testing, engineering, gathering, and more specifically infrastructures to deploy, monitor, and scale these applications. So the three main phases of data engineering is ML model engineering. Sorry, it's data engineering. The three main steps in machine learning design is data engineering. And what does this entail? Starting from data ingestion. Where do you plan on getting this data from? How do you plan on getting this data? How do you get the most out of this data? How do you manipulate this data to get what you want, to get the best out of the data? That is what data engineering is all about. Model engineering. How do you select the best model? Which model is doing best? Which model comes to your mind given a particular problem? These are the questions we are going to answer. And the code engineering. By consider using Python, by consider using Java or C++. But the most important thing is this. How are you, what is your code, what is your methodology? Are you using things like parallel processing? How are you engineering your model? How are you engineering your data? Which coding approach are you using? Do you want to do batch prediction? Do you want to do single prediction? Is your application running locally, or your application is going to run on the cloud? These are the questions you should answer. So after writing your model, first you need to be able to do what? To deploy your code. And this is model deployment introduction. Model serving. Okay. Model serving addresses the machine learning model in production environment. Model saving, addressing the ML model in production environment. How do you want to serve your model? How do you want to address your model in a production environment? Do you want to do you want to run your model on a virtual environment on a cloud provider like Google Cloud? How do you want to really serve your production to the users? Model performance monitoring, observing informed performance on live on-scene data. So since deployment is just the first step, it doesn't mean after deploying this model it is over. You have to continue to monitor the performance to handle things like model drift and data drift. Data drift happens when there's a slight shift in the data. For example, a particular car company is no longer in existence, or the particular cars they are producing is tinted glasses. So do you think that it's going to work? Do you think it's going to work? No. Imagine you wrote code or you design your system to work with normal glasses and you are now having black cars with tinted glasses. Is it going to give you what you want? No. The performance is going to drop, and that is what we are talking about here. Next, model performance logging. Recording every inference request. We have to get logs of we have to get logs of each user's request, and this is where how we want to make this model available comes in. Are you deploying the model and making API available via endpoint, maybe the front end or back end, or do you have this model sitting in each of the individual's device? Model performance and logging. You have to take logs of the activities going on in your model so that when once your model crashes, it will be easier and it will be much more better for you to be able to find, to troubleshoot and debug your model. Data engineering pipeline. So talking about data engineering pipeline, the first thing we need is data ingestion. This means collection of data from different sources. Let's say you want to build a particular software, you want to build a particular problem, and you have to collect data. You have to collect data. How do you plan on collecting this data? There are a lot of different ways you might want to collect data. And then, so you have to make sure there's a source for your data. That's the first step. Number two, exploration and validation. Understanding the data content and structure. After getting this data, you explore your data, just like I said earlier. You validate that, yes, this is the data you want. And with this, you can get what you want from your data. That's what data exploration and validation is all about. Next, you might look at data visualization to get the graph distribution of the data and a whole lot of it. Data wrangling, formatting and cleaning the data. Data most times doesn't come without missing values. How do you handle missing values? You need to write code to handle missing values. We have to take into consideration cleaning the data, making sure there are no missing values, all categorical values are encoded, all the features, all the data that need to be transformed are transformed as well. Next, data labeling. Assigning categories to data points. You have to label your data. More specifically, if you are looking at things like object classification, image classification, or trying to predict infection over disease crops, you have to label your data. You have to label your data. Data splitting. Division of data into training, validation, and test data set. Data splitting, division of data into training, validation, and test data set. So after getting this data, how do you come to evaluation of your model? You can see here that you have to initially, or most before now, you could see that data was split into train test, but we have added validation. And you can use different validation techniques like k-means clustering, can use va- validation like FK fold, meaning that we have where k is a constant. Yes, KF fold, where K is a constant, and for this particular constant, it has a number of times you actually want to validate this data. So given a particular given a particular class of data, we want to be sure that this data you are getting, it's is you are it is give the model is working well, so that we want to take it to the real world. When you take it to production grade, you have what you need. That is what data splitting, division, that is division of data into training, validation, and testing set. Okay, so machine learning workflow. We have said a lot about machine learning workflow. What does this really mean? This means that so far the steps the steps we have discussed is just one is just one. There is no straight route to say after this, after data preprocessing, after data preparation, model monitoring, data training. No, 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 it doesn't work that way. It's an iterative process, meaning you have to iterate, you have to iterate, you have to iterate. What this really entails is that given particular time, or based on the application you are working on, it's a life cycle. You can go from one stage to another, then go to another stage, then come back to stage one, then repeat stage one, then go. I mean, there's no straight route, it's a cycle, it's a loop, it's a life cycle. You continue that life cycle. So that is why if you look at here, we have data preparation, model training, model training, we have model evaluation and iteration, and we have model saving and model monitoring. This is what designing a machine learning system looks like. It's an iterative loop. You just continue over and over and over again till you get what you want. So there are platforms there you can actually use. So example, Vertex AI. I mean, I really love Google and I love Google product. So Vertex AI is a managed ML platform for every practitioner to speed the rate of experimentation and accelerate deployment of AI models. I mean, personally, I use Google Cloud, I use Vertex AI a lot to build RAG applications, to build RAG systems. So Vertex AI provides a suite already. Vertex AI is like a place, is a out of the box non-stop shop for all AI and ML models. So it provides platforms, it provides set of tools you can use to design your machine learning system, starting from how you want to ingest your data, how you want to data storage for your data, how you want to make your prediction. So Vertex AI is a go for deploying your machine learning applications. And I've used Vertex AI to deploy some applications. I've deployed and I mean Google Cloud. I really use Google Cloud a lot to deploy machine learning applications. So a platform for all users and intents through the ML lifecycle. That's what Vertex AI is. Product managers use it, data analysts use it, data engineers need it, data scientists use it, ML developers use it, and ML engineers need it. Let's quickly explore product managers, insights, and objectives. Can you get that as a product manager? You can use things like interactive Power BI, Looker. We have EW in the spreadsheet, connected sheets. Okay, we have natural language query, data question and answer. So these are just few tools you can use as a product manager. For data analyst, that is looking at query and analyzing data, we have endless AW BigQuery. Maybe we know what Google BigQuery is, and we know Google BigQuery a lot. We use Google BigQuery to do a whole lot of things as a data analyst. We have self-managed data pipelines, data fusion, and data flow. Remember, data pipeline. You need to have a source to have your data. Data models catalog, local and data catalog. These are tools data analysts use, and we also have machine learning in SQL. Yes, I mean you can actually do machine learning in SQL. Talking about BigQuery in machine learning. Next, we also have data engineers. How do data engineers use Vertex AI? Using it to clean and get useful data out of the most. So self-driving infrastructures, looking at BigQuery, looking at data flow, and we're looking at things like Composer, where you can use to work with your data to engineer your data. Look at it also provides a broad choice of tools and language, talking about data prog and data flow. We also have data quantity lineage. How do you want to make sure that the quantity of data is, if you are getting a particular quantity of data you need at a particular time? You can use that using AI platform, that is Vertex AI platform, BigQuery and data flow. We also have real-time capabilities using BigQuery and data flow. I mean, it's a non-stop shop for all AI and machine learning workflows. We have data scientists, we have models that work. Data scientists, I mean, most of the works data scientists do is to make sure that you get the best from this data. And to get the best from this data, you need a really working model. We are looking at portable notebooks. We have heard of Google Colab. We have heard of Vertex AI. Now we have Workbench, and we also have Colab Enterprise. Yes, Colab Enterprise. Make sure you go check it out. We have model evaluation and selection. We have explainable AI and experiment where you can quickly do your model selection and then choosing your model and also experimenting with it. We have collaboration and feature store. Collaboration and feature store AI platform and pipelines. Meaning that after, okay, if you actually go deep into writing machine learning system, you know that you need a feature store to store each feature that you use in your machine learning life cycle. And this is what it does. It provides a store for you to be able to work with your features. We have point and click dev, auto ML. Yes, non-technical people these days can build machine learning system. As far as you have your data, upload your data, it will train your model, do the data cleaning, do everything, evaluate, change model. We train your model, make sure it has the best, a good accuracy, and then your model is ready. You can lift it and use it. That is what auto ML is all about. You have to go through that long stress yourself. Okay, so for machine learning developers, we have intelligent apps. We are machine learning engineer. There are a lot of apps you can use. We have intelligent apps talking about images, talking about videos, talking about we have multimodality, meaning we can switch in between modes. That is what multimodality is. Images, vision, natural language processing, intelligence, sentiment analysis with entity extraction. You can all do this these days with NLT translation. We have chatbots and conversational agents as well. Stuff like, hi, Gemini, can you do this? Do this for me, open this. I mean, they are personalized chatbots, they are agents that can do mostly all the work we want to do. Just have to use it. These tools are there. So that's why I said writing code to do this alone is not enough. We have to take it to the next level. We also have fleet routing, forecasting, and optimization. Fleet casting, forecasting, and optimization. When we are looking at fleet cast routing, we want to forecast maybe a feature date of a particular event, time series, and a whole lot of that. You can use optimization on Google Cloud, Vertex AI. We also have ML engineer model in production. ML. So this is where the interesting part comes in. For machine learning engineers in production, this is where the interesting part comes in. We have scalable model hosting using AI platform prediction. Yes, you can build a pipeline, you can scale applications, you can scale a whole lot of applications, your machine learning applications on Vertex AI. You can write continuous integration, continuous development, and orchestration using AI platform pipelines. Yeah, remember DevOps methodologies, first class, continuous integration, continuous development. Yes, for a machine learning system. After I'm going to put all these things together so that we can look at how it works. Imagine having an entire end-to-end machine learning system. How does it feel like? Next, we have provenance and we have provenance and lineage machine learning metadata management. So we also need metadata too, especially if we are building stuff like ranks. You need to know the number of pages. We need to know um other information, metadata of that application or data we are working with. Improving model and retraining. That is where continuous monitoring comes in. We have to monitor your data, our model. We have to monitor this system running on the cloud, running via fleets of different, applications, especially when these models have been deployed already. If anything changes, you need to monitor to be able to catch the bug and then make sure that our system is working accurately well. That's why it's a life cycle. So Vertex AI overview. We have data readiness, feature engineering, training, model saving, understanding and tuning, age, and model monitoring. You have to check this out for yourself. This is super interesting. Data labeling, data sets, feature store, training optimization, experiment, AI accelerator. That is what pipeline and orchestration does. It brings all these things into one place where you can write code to orchestrate your pipelines, including prediction, hybrid AI, continuous monitoring, and using tools like that, and explainable AI. These are all tools available on Vertex AI. We can all check it out so that you don't just end up building applications, sitting down in Jupyter Notebook. So the machine learning model development life cycle, experimenting, training, and deploying. So now let's bring it everything together. How does it really work? How does it sound like? How does it feels like? How does it work? So first we have your data ingestion, meaning we need a data source to actually get in your data. Did you get? You need a data source to ingest your data. You need a pipeline. You need a pipeline to work with data. So after that, we also need to analyze our data. So looking at analyzing our data, um, what are the possible features? Does this data work well? This is what we're expecting. If we are using this data, okay, so far, that is where data analysis and visualization comes in. Let's try to check the most out of this data. I need to transform that data to what our model actually wants, or to what our model will be able to absorb and ingest. For example, maybe converting it to embeddings, vectors, categorical data using one hot encoding and decoding this data. Next, we have training. Can train your model the way you want on Vertex AI. There are also no code, low code tools like auto ML, like custom code. Sorry, custom code, meaning you can customize how you want to train your model. So for auto ML, you just have to in auto ML, you still have your configurations, your custom system, but it's it makes your entire work easier. You can as well say no, I want to customize my model. Then you are free. You can write your code, train and deploy it as well. Let's look at tracking. And what you track is what is models. You have to track model. That is why you have to take logs of your model. You take logs of your model so that you know what happened, what caused, and what you need to do to move to the next level. And let's look at deploying and batch predictions. Yeah, this is where the interesting part comes. Deploying and batch predictions over the server, over edge devices. I mean, it's another thing whereby you have people, you have customers, users using your application in their various devices, in their cars, in their systems, in their applications, their systems, in their mobile, maybe downloading it via the edge and the rest of it. So endpoint and batch prediction. You have to maybe let's say you are working on a product team and this model has to be embedded into applications. You need to provide a point where the user can hook up with and then get prediction. You have to say make endpoints available for either the front end or back end to call your model and use it in real time. This is what design machine system is all about. Once you bring this entire loop together, you see that this model continues. And how do you do this? We do it with code. We write code to make sure that all these things are possible. All these things are being carried out. All these things are done. There's no how we won't get a job. There's no how we won't be hired as a machine learning engineer. Now look at what you have explained compared to just training these models in Jupyter Notebook. We are adding a creamy layer to your portfolio, to your skill set, to your data, to yourself. Okay. So this is this is an entire life cycle that machine learning engineers have to take into consideration. So I mean, the reason you can use Google today is because imagine Google built Gemini and left it in Jupyter Notebook or maybe a development environment, possibly test server. You won't be able to see it, you won't be able to use it. Maybe you have to go to Silicon Valley or anywhere to go and use it locally and come back. So because Google have deployed their AI system. That is why you can have access to it anywhere, anytime. You just have to call the system and use it. Download Google today and start using Google. As simple as that. Imagine Google was not, or Google, let's say Gemini was not deployed or wasn't made available for in production. I mean, it will be very, very difficult to use. So here is the history of productionizing Google and machine learning at Google. We have continuous training for deployed for production machine learning in TFX program 2019 up to 2015. We have slice finder, automated data slicing for model validation. We have data validation for machine learning, SysML 2019, TensorFlow X, a TensorFlow based production scale machine learning platform KDD 2017, data management challenges in production machine learning SIGMOD 2017, rules of machine learning, best practices for machine learning, Google AI Web, yeah, 2017, machine learning, the high interest credit card of technical debut. Wow. Wait, these are all interesting things you could go look up. The link to the slides will be provided in the description or any in the link you are just seeing it, maybe on Medium or my LinkedIn account. Hidden technical depth in machine learning systems. Hidden technical depth. So can all these are links we could click and learn more about designing machine learning system. Easy and proactive monitoring of model performance. For models deployed in Vertex predictive service, you can monitor your model and have an alert in real time. Monitor signals for models predictive performance and alert when those signals deviate. You can diagnose these models. That is, help identify the cause for the deviation. That is what changed and how much change. That is if you are using Vertex predictive service. Also, update models, trigger model retraining pipeline, or collect relevant training data to address performance degradation. This is what a pipeline, this is what having a pipeline does. Anytime there's a model drift, content drift, or even data drift, you can as well retrigger the training. And you cannot retrigger the training if you don't have a feature store, if you don't have a pipeline. You need to understand what a pipeline is. And end to end, you have your data store, you have your logs, you use these artifacts to do some measurements, to do some analysis of metrics, then you will trigger with the new data you have. Simple. So scalable endpoints with vertex prediction, models trained with auto ML, unified endpoint experience, and models trained with custom code. Have a unified endpoint experience, and you can as well self models built with most commonly used machine learning frameworks, split traffic between models, customize endpoint machine types. We just explained this. These are the things you need to consider as a machine learning engineer. Making available endpoints, whatever you are doing, and the whole lot of it. Cloud native AI platform. So the tools we can actually use to build machine learning, depending on whether you are looking at whether you are looking at um, Kubernetes, or you are looking at Docker, GPUs, CPUs, or how, depending on how you want to self or deploy your application. We have ML framework plus containers plus Kubernetes plus HW accelerators. So like we all know, the traditional machine learning frameworks or industry accepted machine learning frameworks include TensorFlow, Caffe, Spark, Keras, Skyscale, Beam, R, and the rest, and a whole lot of it. So you can choose your favorite machine learning pack models up in containers or run. So I'm talking about things like Docker, Container D. So the same way you run your application for DevOps, you can carry it and then make it available, and then bring those set of practices for machine learning applications. After training your model, you bring your model to a development environment, maybe like VS Code or PyCharm or any development environment or Jupyter Notebook. You containerize your model. I know some people just want to like write fast API and just from fast API make the model ready in real time. Well, it's good for project, but if you are looking at large scale, if you are looking at what the users could be able to use, you have to containerize your model so that you have the issue of installing and setting up development environment anywhere this application is being used. That is the promise of a container. Next, we have containers run on Kubernetes at scale. We also have hardware accelerators like Google Cloud. Yeah, I use Google Cloud a lot and I deploy on Google Cloud. Looking at CPUs, GPUs, and TPUs. I mean, these are machine learning systems. They are very heavy. If you look at core, if you go deeply into the core of machine learning, you see how all these things are done. They are very heavy and need to be executed on powerful devices. So these are resources: Vertex AI, Vertex Machine Engine documentation, our built-in algorithm for building recommendation service quickly. TensorFlow recommenders, building two tower models is switch swipe models for recommendation, TensorFlow similarity. So these are links to tutorials you can check, you can use and read. So at this point, thank you everybody for staying to the end of this tutorial. Please do well to drop your questions in the comments. Yes, you can retweet if we saw it via post. Drop your comments there, tag the community, or you can tag me. Your question will be responded to. And as well, please do well to subscribe and follow this channel. The link to join our community will be shared here. And in the meantime, thank you, and I hope you learned something new. See you next time.